Hi, class. So one thing that you looked at in Chapter 8, Haller Statistics, is they talked a little bit about the idea of extrapolation, which is applying like statistical techniques where it doesn't make sense, right? So the idea with extrapolation is where you're trying to make predictions either after where you have data from or before where you have data from. So you don't know exactly where what's going to happen afterwards or before. So it becomes very dangerous to use extrapolation. And I had you reading something out of a lower level statistics book as part of the linear modeling project. And then there was a question in part B that dealt with this. So kind of the idea, the theory, if you will, is if I have a scatter diagram, and let's say, I don't know, this is years, and maybe number of cars on the road. Right. So then if you had a scatter diagram of this, it had some data, and let's say this starts the year 1960 and we have data through 2010, then the way the data is presented, this looks like a very linear relationship. So maybe I might have a line of best fit that looks something like this. So our data looks to have this overall positive linear trend. But it's very possible that outside of our data range, we don't continue to have a linear relationship, right? We don't have the whole picture. So maybe after 2000, maybe our data starts to flatten out, right? So we have something like this overall trend going on, where years after 2000, it doesn't necessarily end up in this linear fashion up here. Right. So let's look at this specific example here that I laid out for you in these notes. So I'm letting x denote the year, and then the y variable to be the number of people living in farms, right? And I put this in thousands as a unit, right? So here's our T chart here. Right. So I'm going to use Excel to create a scatter diagram for this, and to save some time, I went ahead and threw this data in Excel. So I just typed it in the year and numbers and farms. So we can highlight my data. I'm going to go to insert a scatter diagram. So this is the overall graph that I'm getting. So then I can right click on this. We're going to add a trend line. So let's do a linear trend line, and then I'll do display equation on the graph. So this is the overall equation that I'm getting, right? And so if you look at this, the data does appear to have a linear trend, right? But one thing you want to keep in mind is that this vertical axis, these are a number of people that are living on a farm in thousands. And one thing to keep in mind is eventually this line it has a downward trend, so eventually it's going to have a point where we're going to have negative values, right? And that doesn't necessarily make sense for our problem, right? It doesn't make sense to have negative people living on a farm. So let me minimize this and go back to the example. So part A, we're given an equation, and you're asked to predict the number of people living in the farms in 1985, right? So if we look at our data, we're using this to estimate what happens in between 1980 and 1990, so 1985, right? And this actually is not extrapolation. This is called interpolation. Right? So interpolation is where we're using our line of best fit to estimate in the range that we have data for, right? So in between the years 1940 to 2000 is interpolation, and then if you try to use the line of best fit to estimate before 1940 or after 2000, then that would be called extrapolation. So part A is an example with interpolation. So we have our equation, y equals negative 461 thousandths x plus 921 and 58 hundredths. And we want to predict the number of people living in farms in 1985, right? So in other words, we're told that x is 1985, and I want to know what will y be. Right? So we can certainly do this. Let me pull up a calculator here. There we go. Right. All right. So we want to solve this. Y equals negative 0.461x plus 921.58. So we're putting in x values equal to 1985. So we need to simplify this. So we get 0.461. Need to make this negative, and then multiply that times 1985. And then we need to add in our y-intercept. So we get a y value of approximately, what was it, 6.495. So this, in the unit here is in thousands. So this would actually be 6,495 people, right, that are living on farms. And you can see this sounds reasonable because in between 1985, we had 7.2 thousand people in 1980 and 3.9 thousand people in 1990. So our answer of roughly 6.5, is reasonable here, right? So 6.5 is in between 7.2 and 3.9. So so that makes sense. All right. So then the next problem here, part B, says predict the number of people living in farms in 2030. Right. So this is hinting to the fact of extrapolation. So notice that if we look at our data set, 2030, is clearly outside of where our data is, and we're trying to use our line of best fit to figure out what this y value would be for 2030. So we still have our same equation, y equals negative 0.461 times, and I'm going to put 2030 in for x, and then plus 921.58. Right. So if we go ahead and put this in the calculator, 0.461, make that negative, times 2030, and then add in 921.58. We get negative 14.25. So y comes out to be negative 14.25 thousand people. So what's wrong with this is this number doesn't make sense. Like as I was saying before, it doesn't make sense for us to have negative people living on farms, right? And theoretically, we're always going to have farms. I mean, we might have less of them and less people living on them, but we certainly, need farms to survive. So, I mean, I would, it's almost like an implied range that our y value is always going to be above 0, right? So it's kind of implied that y should always be bigger than or bigger than 0, right? Not equal to 0, because we need farms. Right. Also, it just doesn't, like I said, it just doesn't make sense to have negative. I mean, we can certainly have 0 people living on farms, but negative people doesn't make sense. So this is where the extrapolation becomes dangerous, right? So if we go back to our graph, so we were estimating for 2030, which would be like down here. It just doesn't make sense. So if we're going outside of the our range of data, so we have data between 1940 here and 2000 here. So trying to use our line of best fit to estimate after the data or before the data is dangerous, because we don't know the pattern, we don't know what happens, we don't know if the graph changes. So that's the piece of information that I want you to know about extrapolation. Right. So feel free to send me emails if you have more questions. I'd be happy to help you. Thanks.